Okay, so we are going to do what's called solving differential equations, which you've kind of done before. But we're going to do it in a way where we actually have to separate the variables. Okay? So when I say separable differential equations, I'm referring to what we do today. Okay? There will be a time where you cannot separate the variables, and that's when you take the class called differential equations, and that's basically what comes after Calc 3 in your math progression in college, if that's the route that you use. Okay? But separable differential equations we can do in Calc 1. Okay? So remind me what I would do here. If I wanted our function, what would we need to do? We would need to take the antiderivative. Okay, so we know that f of x would be 1/2 x squared plus x plus some constant c, right? Okay, well, the differential equations that we are going to work with are going to have a derivative that's equal to a function of g and a function of y mixed together. Most of the time we'll see division, but sometimes we will see multiplication. Okay? Because we have x and y both together in our derivative, that's why we have to say we have to separate the variables so then we can take the antiderivative. So I'm going to give you kind of some pointers as far as like the order in which I think you need to do things, and then we'll just do some examples. Okay, we have 4 examples I would like to get through. Okay, fingers crossed. These really don't take a lot of time, but we're going to have an interruption, so. Okay, so, very cool. Sorry. So when we solve differential equations, okay, first of all we have to do what's called separation of variables. Okay, don't write this second line. Let's just start here. Separation of variables. Okay, since we have x's and y's, yes, we're going to need to integrate, but we need to integrate with x's together and y's together. Okay, so the first thing you're going to need to do is you're going to need to put y, anything with y on the side with dy, and anything with x on the side with dx. Someone's Siri going off there? Once your x...
Good morning, this is Mr. Seals, this is the principal of Nathaniel Vista South. In just a moment, we will be going into...
So let's continue. Once y and dy are together, any x's and dx's are together, then we can integrate both sides. And then we can solve or clean up the equation as necessary. What do I mean by that? We like equations, so like y equals if we can. And so I would ask you to solve for y at that point. Maybe there's some reducing we can do, things like that. Okay? Now, when I ask you for a general solution, okay, this is what you're going to give me. Since we're integrating, there is going to be a plus c involved, right? However, if I give you a coordinate, we could find a particular solution. Like here is our derivative, and we know it goes through the point 1, 2. We could actually find what c is. So if I ask you for a particular solution, then you're going to do what you did before. You're going to integrate with separation of variables, but then you're actually going to find what c is. and write the solution with that value of plus c. So what we are going to do is we are going to do two general solutions and then two particular solution examples. So a total of 4 examples to each. Okay? Very straightforward. Are you ready? No? It's not. Okay? dy dx equals 3x squared over y squared. Okay? I do want to take this time to remind you that dy dx and y prime mean the same thing. If you get to a problem and it says y prime equals 3x squared over y squared, just change it to dy dx so you can do the separation of variables. Okay? This one is set up very nicely for us. Okay? In order to get our variables separated, what do we need to do? Cross multiply, right? We can multiply that y squared over with the dy, and we can multiply that dx over with the x squared. So we're just cross multiplying here. Okay? At this point, our variables are separated. Y's on one side, x's on the other. We can actually perform our integration. Okay? Antiderivative of y squared. What do you have for me, Eli?
1/3 y to the third plus c.
Okay? And the antiderivative of 3x squared. Trevor?
X cubed. Oh, plus equal.
Okay. Here's the deal. We have added a constant to both sides. What happens when we add constants together? They could be different, so whether they cancel or not, we still have a constant. Would you agree? Whether it's 0, 5, 1.2, pi, I don't know. So it's kind of redundant to have plus c on both sides. When you do the separation of variables, it is a-okay to just put your plus c on the x side. Because what are we going to eventually have to do? We're going to have to solve for y. So it's okay to just automatically combine those plus c's to just be on the side with the x. Okay? So we have found our antiderivative. The only thing that we need to do now is solve for y, because that's how we like our equations to look. So to solve for y, we would need to multiply by 3. Instead of writing 3c, you can still just write c, because 3 times a constant is still a constant. Now, is this c the same as the c that we wrote originally? No, but we don't really need to worry about c until the very end anyway. Okay? So then at this point, I would ask that you solve for y by taking the cubed root of each side. And this is our general solution to our differential equation. Okay? We have an infinite number of solutions because of that plus c, but they are all in this form. Does it feel like I really taught you a whole lot of new? No, it really doesn't. Okay. So that's kind of nice. Does it bother anybody that I'm starting with section 3?
It bothered me.
Bothered you? Okay, I do have a method to my madness. Okay, it bothered me at first too, but it's kind of nice to start out with this, so then when we get to 6.1, we can understand why we have to do what we do in 6.1.
Is it like one of those things where in the book it teaches you the shortcut later on, so you're just teaching us the shortcut?
It's actually not a shortcut, okay? What happens is we can't solve every single differential equation, okay? So we have something that we look at in section 1 that can help us determine what solutions are, okay? But I want us to know how to solve some of them first, okay? Next example, write it down. dy dx is y over 1 plus x. Okay, so to separate variables, we have to multiply and divide some stuff, right? We're going to have to divide the y over, and we're going to have to multiply the dx over. The antiderivative of 1 over y. Think about it. It's been a while. Yes, natural log 1. Okay? Remember, I'm not going to put plus c on this side. I'm just going to wait until the other side, since we are integrating both sides. The antiderivative then of 1 over 1 plus x. Yes. Okay. We've gotten through the easy part. Now we need to solve for y. What is the inverse function of the natural log? Okay. So you can think about it a couple different ways. But essentially, in order to cancel out that natural log here, I'm going to exponentiate both sides. So e to the natural log cancels out, and I have y equals e to the natural log of 1 plus x plus c. Or you can think about rewriting, and it gets you the same place, right? Now, why doesn't e to the natural log of 1 plus x cancel out right now? Because it has the plus c. Now, let's recall, when we are adding in our exponent, that means that we have multiplication with the same base. It's kind of working backwards is what we typically do, right? So let's think about it. If we have multiplication with the same base, then we add our exponents. So what I've done is I've taken our exponents that are being added, and I've broken it up to a multiplication problem with the same base. Okay? Why is that helpful? Well, now we can do e to the natural log cancels out. Do you agree? Okay? And e to a constant. E to a constant is still going to be a constant. Not the same constant as up here, but e is a constant raised to a constant power is still going to be a constant. So we can just write it as some constant times 1 plus x. What else?
Same face everybody makes me like I'm.
Well, I didn't expect you.
Okay, I'm an intruder. What do you do? What can you do?
Fight back.
Fight back. That's an option. It's not going to be an option for everybody, but it is an option.
Okay. Now let's go ahead and move on to particular solutions. Now I'm giving you a differential equation that we can solve with separation of variables, but I also give you a coordinate on the graph that we need to actually use to find our C value. I go? You seem ready to go. How do we separate these variables? Okay, so we have y dy equals, I'm going to go ahead and leave the negative with the x. We know eventually we're going to have to solve for y, so I think it's going to be to our benefit to have that negative with the x no matter what. Do you agree? Okay. Okay. So y dy, antiderivative, 1/2 y squared. We're going to leave the plus c just for the right side. So we have negative 1/2 x squared plus c. Okay. Okay, here is where our plus c's could be different depending on where we decide to plug in. Some of you may decide to find c right now, and your c would be different until you solve for y. Okay? Some of you may choose to go ahead and solve for y and then worry about that plus c. So we all know that we're going to need to solve for y. I'm going to go ahead and find the general solution first, and then we can worry about our plus c. Okay? So if we're going to find the general solution first, we would multiply by that 2. So we have y squared equals negative x squared. 2 times c is still a constant. This is where that c would change depending on where you plug it in. But by the end, it's still going to get to the same place. Okay, so it's a good conversation to have. Y equals, plus or minus, radical, negative x squared plus c. Okay, this is your general solution. Okay, you guys recognize that? Okay, it's a circle. The two put together, basically it's 2 semicircles, right? Positive is the top semicircle, negative is the bottom semicircle. Okay, now when we actually go to solve for our c, we don't want both plus and minus. Y of 4 equals 3. That means when x is 4, y is 3. Do we need to choose the positive or the negative? Why the positive? Okay, here our y value is positive, right? We want our y value to be positive. So we're going to choose the positive value. If this y value is negative, we would want the negative radical, okay? So we're going to say, all right, y is 3, x is 4, in order to solve for c, we would need to square both sides. So c is 25. No matter where you plugged in the 3 and the 4, you would still get to the particular solution of y equals positive radical negative x squared plus 25. No matter where you plugged in that 3 and 4, you would still get to that same particular solution. But if you plugged in right away, you wouldn't get 25 for your c initially, but then it would reduce after this. Oftentimes, like in an AP free response problem, they're going to ask you for the general solution, and then in the next part of the question, ask you for a particular solution. So I think it's just a good idea to solve for y first, and then plug in your c. All right. Last example, and then you're going to get some time for your homework. Look at that. I'm worried about time. about this? Since we have some time to work with, I want you at your pod to get to the general solution. Don't plug in 1 and 3 yet. I want you to work on the general solution. Okay, I'm going to give you a couple minutes to work together, and then we'll go over it on the board. I know, you get in that natural logarithm, and then...
A bunch of minutes left over from our Orlando trip. Basically, yeah. It was a lot of fun. I liked Universal Studios. I've never been there before. I went to Disney World in like 3rd grade. I honestly like don't remember anything from my youth. Because like I went there, and, like the only things I remember was like the Star Wars thing at Universal Studios, Main Street and Magic Kingdom. But it was a lot of fun.
Well, Callie, when we separate variables, what does that look like?
1 over y equals
Good morning again, this is Mr. Seals, Assistant Principal at Plano Vista South. At this time, the entire drill is complete. Please continue with class and then proceed normally with your day. When the bell rings, we are out of lockdown at this time. Thank you for your cooperation. Now go learn.
Say, we've been learning, Mr. Steele, right?
Ben has learned.
Okay, so I like that Callie said x to the negative second. If you did this, don't feel bad, because I would say about half the class was like, oh yeah, 1 over x squared, natural log of x squared. Okay, very tempting, especially when we're in the rhythm of using the natural log of x for a 1 over x or antiderivative. But don't forget about our power rule, okay? So, which is why we're doing this example, okay? So we're gonna take our antiderivatives, okay? Michaela, what are our antiderivatives? Okay, good. And so then when we solve for y, we get y equals e to the negative x to the negative first plus c. Negative ones aren't looking very negative one like, but we'll keep rolling with it. Okay? Okay, so remember we can break up our exponent so that our e to the c we can write as c. Okay, and I'm going to go ahead and write this as negative 1 over x. Okay, now by writing our c in this manner, it's going to be a lot easier to solve for it. Okay, because we're just going to have to perform a simple division problem as opposed to using all these crazy natural logs and whatnot. So getting to here is way better than trying to solve for c here, and this is what I expect. Okay, so now our initial condition is the coordinate 1, 3. So we are going to plug 3 in for y and 1 in for x. Okay. So when we divide e to the negative 1 over, it really just becomes e to the first. Okay with that? Hello. Thank you. So then to write our particular solution, our c value is 3e. Okay, now that looks kind of silly, doesn't it?
Plus 4. Or no, plus, right?
Well, yeah, we have, this is e to the first power, so we can combine these to be 3, and then e to the 1 minus 1 over x, or negative 1 over x plus 1, however you wish to write it. I just think this looks a little bit nicer. You can even write the exponent as x minus 1 all over x. I mean, there's a number of ways we can write that exponent, but this is the type of answer I would expect. 3 e to just 1 exponent. Okay? All right. So